So hi everyone, myself Rekha, Assistant Professor, Department of Mathematics. So today we are going to represent the Chi-square test and some of the concepts of the Chi-square, definitions of and formulas for the Chi-square, and how to apply the Chi-square for the small sample test also we are going to explain. So in this comes under the course Discrete Mathematics with Probability and Hypothesis Testing. So before going to enter into that problem, so I am going to explain what is Chi-square test and how we are going to state the uses of the Chi-square. So this Chi-square is nothing but a non-parametric statistical test used to determine whether there is a significant difference between the observed frequency and the expected frequency in one or more categories. So this Chi-square is more or the observed and help us to expected frequency. And the formula for the Chi-square is summation O minus E the whole square by E. O is nothing but observed frequency, whereas E is nothing but an expected frequency. And these frequencies we have to calculate using the table, and the null hypothesis is accepted. And what are the uses of the Chi-square is nothing but Chi-square is mainly used to test the small sample test, and especially so it is a test of goodness of it we can say, and it is the test of independence attributes, test of homogeneity, that is nothing but whether difference population have a same distribution. So analysis of a contingency table used in two-way or multi-way tables, and testing hypothesis in social science also we are going to discuss. We have to apply in the Chi-square test. This is applied in widely in the economics, management and sociology, etc. And next is nothing but one simple problem. That simple problem also they have asked the concept of formula of the goodness of fit at Chi-square. So already discussed in the previous section. So this can be represented as a goodness of fit on, that is Chi-square equal to summation OE minus OEI the whole square by EI. So this is calculated by the degree of freedom, and the Chi-square goodness of fit compares the observed and expected frequency to determine whether the difference is statistically significant. And how to calculate the formula using the independence attribute in Chi-square is nothing but Chi-square test for the independent attribute. We test whether the two attributes are independent in contingency table, that is expected frequency formula is nothing but row total into column total by n, that is Chi-square statistics is nothing but Chi-square into O minus E the whole square by E. And so if you comes under the concept of the table, we have to calculate the A alpha means B means A into B, and alpha into B we have to calculate, beta means A into beta, alpha into beta we have to calculate, and total value we have to find the row total and as well as the column total. So E can be calculated by multiplying the row total into column total. And if we want to go with the properties of the Chi-square distribution is nothing but Chi-square distribution have the following property, that is non-negative values, continuous distribution, right skew distribution, depends on the degrees of freedom, mean and variance, become a symmetric for a large value, additive property, and the problem makes the Chi-square distribution, that is widely used in the goodness of fits and as well as the test of homogeneity. And let us see the problem based on the Chi-square. A retail chain manager complains the customer footfall in the stores evenly across the 6 days it's open, and 16.67 of week customers visit on each day, and over a period 8 weeks a total 720 customers were recorded. They have given the days of week observed frequency and expected frequency we have to calculate. So how to calculate means we have to calculate the value O minus E the whole square. So first of all list out the day and as well as the observed data and expected data. Already the total customers mentioned as n equal to 720. Number of days is 6, so we have to divide 720 by 6, we will get 120. So we can write the expected value. After writing the expected value, we can calculate O minus A, 98 minus 120, and that value whole square means we will get 484, and that will be divided by E means we will get 4.03, 2.70, 1.20, etc. And this is 0.83, 4.03 and 13.13. And next Chi-square can be calculated as 4.03 and all the values we have to add. So the degrees of freedom also we have to calculate n minus 1, that is 6 minus 1 equal to 5. So that is equal to 11.07, that is greater than the calculated value, means we will reject the null hypothesis, and we conclude that the 5% is significant level data. The footballers are not uniformly distributed across the 6 states for the higher than the customer value visit. So thank you for watching this Chi-square test and problems, basics of the Chi-square, for watching this video.